When trying to write a function to model some kind of data, whether it's a table or a graph or a situation, the first thing is to try to figure out, is the function actually linear? Because sometimes you're going to encounter functions that aren't linear, so it's going to be very difficult, impossible, to actually write a linear function to model it because it's not linear. So in order to determine if a function is linear or not, if you're looking at a table, we're going to decide, does it have a constant change the whole way through? So here it's going up 2, up 2, up 2, up 1, up 1, up 1. So because the slope is 2 over 1, 2 over 1, and 2 over 1, the whole way, this is linear. Because it's 2 over 1 the whole way. For this one, it's going up 5, up 10, up 5, down 3, down 3, down 3. So the slope starts out being 5 over negative 3, and then it goes to 10 over negative 3. And those two slopes are not equivalent, so this is not linear. Sometimes the slope can look different, but still be equivalent. For example, if this said 10 over negative 6, they would look different, but 10 over negative 6 is equivalent to 5 over negative 3 because it reduces to that. So then it actually still would be linear. Let's look over here. It's going up 2, up 4, up 2, up 4, up 8, up 4. So the slope starts out being 2 over 4. Then it's 4 over 8. Then it's back to 2 over 4. And even though 4 over 8 looks different than 2 over 4, it's actually equivalent. It reduces to 2 over 4, and then all of them actually reduce to 1/2. So this is linear because there is an equivalent slope the whole way. Okay, so because there is an equivalent slope the whole way, this function is linear. It looks different, but that's okay, it's equivalent. For a graph, you're just going to look at that graph and decide, is it a straight line the whole way? You can pick several points. And determine the slope between them. Are all slopes equivalent? And if they are, then it is a line. Now look here. Look at this situation. Well, for a situation, it says, does the situation increase or decrease at a constant rate? So for a situation, you can make a table that models a situation and then decide. So this first one says, a girl saves $30 each week from her new job. So let's make X be the weeks and f of X be the money saved. So if she works 0 weeks, then she has $0. If she works 1 week, then she has $30. If she works 2 weeks, she'll have $60. If she works 3 weeks, she'll have $90. So this table models that situation. It's just a list of how much money she'll have saved after each week. So over here, the slope is 30 the whole way. Over here, it's 1 the whole way, so that would be linear. Over here, it says a baby doubles in weight every 6 months. So we don't actually have a starting weight here. So we're just going to make one up. Our X is going to be 6 month periods. And our f of x would be weight. So let's just say that when the baby is first born at 0 6-month periods have gone by, let's say that baby just weighs 8 pounds. And then after 1 6-month period, now that baby weighs 16 pounds. After 2 6-month periods, that's going to double again because it says it doubles every 6 months. So now it's 16 doubled is 32 pounds. And then after 3 6-month periods, now that baby is 64 pounds. It's a very big baby. Is this a linear function? So here it's going up by 8, up by 16, up by 32. Over there it's going up by 1. So we have 8 over 1, we have 16 over 1, we have 32 over 1. So 32 over 1 is our last one. The slope is always the y over the change in x. And so this is not linear because these are not equivalent. Now words like doubles, triples, things like that, all of those are going to be functions that are not linear. So if you see a word like doubles or triples, or like splits in half, things like that, anything like that is an automatic cue to you that that is not a linear function. So hopefully you have a better understanding now of how to determine if a function is linear or not. It's really just all about looking at the slope and determining if the slope is equivalent the whole way.